Okay, it's noon Eastern, 11 o'clock Central Time. We'll go ahead and start this second in our series of drought response webinars. Yesterday, and having the recording of this posted, but yesterday we did a discussion about nutrition management for livestock during drought situations. And today we have emergency livestock watering. One of the things that we've seen so far is that in some areas across the state, ponds are drying up. Some springs have stopped flowing with the same kind of volume that they normally would have, and some creeks drying up. So certainly water being the most important nutrient for livestock, wanted to go ahead and address that. And we're lucky enough to have Brian Leib here, who's our biosystems engineering and soil science department. When we did some drought response work in 2012, put together a really nice presentation on some of the things we need to think about in hauling water, pumping water, just generally in emergency situations, getting alternative sources to water for water to our livestock. So, Brian, I appreciate you being willing to really quickly put this back together and present it today. And with that, I'll turn it over to you.
Yeah, thanks, Justin. Appreciate the opportunity to speak on this. I guess who would have thought on November 1st in Tennessee that we'd be in a somewhat of a water crisis. I know here in Knoxville it hasn't. I guess in the last 10 weeks, I think we maybe got about an inch of water. I think other places are worse, and some places have done better than that. But so what I really want to try to accomplish today is to give you take a look at several methods that could be quickly deployed as a watering system. I mean, all of them will take a little time and effort, but it's not something you'd have to do intense planning and maybe wait for a lot of other people to do their job before you could get water to where you wanted it. And in doing that, I guess we're going to take a look at the technical feasibility of these methods, and then also the cost. So again, just to help you weigh the options you have in front of you that might help solve your problem in terms of watering livestock. Whoops, I thought the button would advance it. I guess not. Let's see. Okay, I've hit a different button. So I guess where we need all start is what are the requirements for livestock, and here I put up some slides from some other UT members on horse, sheep, and goat water requirements. And of course, a horse being a bigger animal, if you look here on your left, you can see with high temperatures and moderate exercise, the water requirement per day can be pretty high, above 20 gallons per day, as compared with sheep and goats, smaller animals. It's more like 1 to 5 gallons per day, or less than 5 gallons per day. Cattle may be our biggest interest, and again, there's a range depending on size of animal and whether it's lactating or not. And so here in some of our warmer months, you can see we get close to 20 gallons per day for nursing cows. And so again, I guess just to go through this presentation and use some more solid numbers, I'm going to use as an example, for my examples, I'm going to use 25 gallons per day, cow per calf per day, to go through some of the things I'd like to show you. And again, that's pretty conservative, but if you think there could be evaporation losses and leakage losses and things like that, maybe that's a fairly good number to work with, but it should be conservative. I guess the first thing I would look at if you're running short of water and your usual sources for your livestock is what other potential water sources are around you. Is there a house well system? Is there city water? Is there another stream you haven't usually thought of using? Or some other pond that's not generally used in certain locations for your livestock that you could pull to? I guess you could also even start thinking about neighbors' resources if they might be willing to share or let you purchase some of that resource from them. So how far they are, and things like that would be important, and where they're located in terms of elevation would be important to note too when you're thinking about these resources. There's a few hydraulic facts we can't ignore if you want to work with water systems. One of them has to do with the pressure of water. I know you all watch these submarine movies where they go so deep and eventually the submarine is about to pop, but they save themselves. Well, that is a reality. The more water you have over top of anything, the more pressure it creates, or you need that energy, same amount of energy to lift water higher. And so we usually say 2.31 feet for a PSI. Maybe it's easier to think in 10 PSIs, and about 23 feet would create 10 PSI, or conversely, you need 10 PSI to get water up 23 feet. So I guess why I think that's just an important thing to note. If you pick out a pump or tap into a system that has 40 psi and you were planning to lift water over 100 feet, you're going to be sorely disappointed. Water's not going to get that high because you just don't have enough energy to lift it that high. So when we talk about sources of energy to move water, I think in our situation with a short turnaround to get it done in an emergency, we can think about gravity if we have sources of water that are uphill. We can think about existing pressurized supplies like a house well or an irrigation well or a city supply. Or if we're going to go to a pump, we're probably not going to get an electric type motor pump in there. We're probably going to be talking engine gas or diesel driven pump to get that done in a shorter time frame. The other thing about hydraulics I think you have to think about a little bit, I show a little example. If you wanted to move 20 gallons per minute and you tried to move it in a 1.5 inch pipe versus a 1 inch pipe, you'd have a lot more friction loss in the 1 inch pipe. And so in this case, I think this was done with PVC, but and friction loss is different for all pipes, but you'd be losing 4.5 pounds of pressure for every 100 feet. So if you had to go 1,000 feet, you'd be losing close to 50 pounds of pressure before you even got to where you wanted to go to try to move that kind of water. Whereas a 1.5 inch pipe would carry that same flow of water with less than 1 psi of pressure loss. So you can see it wouldn't let you not get any water friction loss, but it would reduce the flow through it if you picked an undersized pipe, and that could be important. So anyway, those are a few things. I guess, again, in emergency, we're probably not going to be laying underground PVC in a short time frame, so we're probably mostly going to be talking about lay flat and poly pipe on the ground surface as a way to quickly deploy some pipe. One of the first things that comes to mind in a water emergency is hauling water. And so you can purchase tanks. Tanks, usually the cost of a tank comes out about $1 per gallon of storage. So you see a picture there of a nice sized 210-gallon tank that fits nicely in the back of a pickup. The weight of water is not excessive. It's less than 2,000 pounds, cost around $200. Again, if you want to go a little bigger, the 450, you might be able to fit this in a pretty sturdy truck, but you have to realize it's going to be taller and not very stable and pretty heavy, close to 4,000 pounds. Again, getting close to 400. And then if you go to a bigger tank, say this tank size of over 1,000 gallons, you're probably going to have to put it on a trailer because it weighs so much. And again, priced about $1 per gallon. Well, what about these size tanks in terms of servicing your herd? And so taking that 25 gallon per cow-calf pair, if you had a herd size of 10, what would be the days between tank trips that would be necessary? So if you had 10 drinking 25 gallons per day, you can see that this one tank full is going to last you about a day. And then you're going to have to go get another tank full by the next day at least, probably. Whereas if you had a bigger, say 20 head or something, 25, you're going to be making probably at least 2 trips with that smaller tank. So in that case, you might jump up and think about the bigger tank and say, well, I can maybe get down close to 1 trip a day if I had 25 head. Or again, you can go bigger and you can, even for 50 heads, you can get enough water for 1 day in 1 trip. So in one sense, this looks like a pretty good solution. This isn't, I mean, these costs are somewhat high, but it's a permanent piece of equipment that'll stay with you. And so you can make a decision like this and get it together and haul water. This type of system doesn't necessarily have to have a pump, but pumps might be necessary if you're going to have to lift the water into the tank and get it in, or if you have to get the water out of the tank to higher elevation. Otherwise, it's already pressurized. You can just let water flow into the tank from the pressurized source and then use gravity to flow into the containers that you want. But I think another factor to think about, again, I think this is a pretty good solution and you might have to consider it. The other thing you have to think about is labor costs, if you want to count that. Maybe in an emergency we don't count labor costs, but I've got to thinking if it took about an hour to an hour and a half, depending on the tank size, to unload and load water at $12 per hour, and then the speed to travel from different distances, how far you had to go to that source of water, and then how fast you could transfer water, and the cost of the travel on your vehicle. If we start adding some of these, and you can see the trip cost, how much it costs to go get that water, and then if you start dividing that by how much per cow-calf pair, that's a pretty expensive proposition if you have to pay for labor or if you want to count your own labor costs. Of course, it's going to be a lot less expensive, and it's an emergency. So wear and tear on your vehicle and your own labor it makes this a lot smaller and doable. But if you really have to pay someone to do it, the time involved could make it pretty expensive. So just something to keep in mind when you look at that choice. Moving on to another type of choice. There's portable pumping system, these small gas-powered engines with a gas tank on top. We can lift water from ponds and streams and get it to where we want it to do. I worked on an example here just to help you think about this a little better of using, say, 2-inch lay flat. That's some lay flat pipe there, and a fairly small. You can get them smaller than this. A 6.5 horsepower Honda motor that's a high pressure pump. So this pump at its highest pressure will develop about 80 psi pressure at 20 gallons per minute. And actually, this lay flat is only really rated for 80 pounds of pressure, or it would break. So with that kind of limitation, we're kind of limited to how much elevation gain we can push that water, probably about 150 feet. Else you'd need a different pump and some heavier pipe, which you can get, but it gets more expensive. What I tried to do in this looks really confusing. I hope it's not if I explain it, but what I tried to do is how much transportation distance can you expect out of a system like this if you had, say, 100 feet of lift to overcome? Well, with this pumping system and 100 feet of lift, and if you wanted to move just 20 gallons per minute, you could get close to 2 miles of length of pipe and deliver water at 20 gallons per minute, which is, you could deliver 3,000 gallons in about 2.5 hours at about $5 worth of gas. So you can move a lot of water cheaply in a short time with a system like this. In fact, if you can, you might want to think about sharing this with other people, because you could spend a day filling a pond and get a lot of water in there and store it for maybe a week or several days, and then somebody else could use it and you can move on from that. But anyway, again, this is just a look at what your situation might be and what you could expect to do with a pumping system. The costs are the thing, I guess, that may jump out a little bit at you at the next slide. So, these small pumps aren't very expensive, $650 to $700 for a pump like this. You need a suction side pump. You need something that won't collapse on this side, because there'll be negative pressure and it has to be rigid. You couldn't use lay flat. And then really the cost maybe comes down to the lay flat pipe going out of this system. It's about $120, and you'll need couplers. Usually we use aluminum couplers that are fairly expensive. So about every roll is going to cost you maybe $120 for 300 feet. And you can start to see, as you add more distance you're trying to go, if you're getting up to half a mile close, again, your prices are getting up around $2,000 or more. So that's a pretty good expense. Again, in an emergency, it may be worth it, maybe really worth it if you can share it with your neighbors. But this is really not a very good permanent system. You have to think that these things laying on top of the ground aren't going to last if they're let out there to be mowed over and walked over. They are meant to be run over somewhat. We've run over some for 5 years on gravel roads, and they still last, but they can be chopped up. So again, this is one system. If you need to lift water out of some source and get it to where you go, I mean, it's doable with some expense involved. Another situation, I don't know if we'd hit this situation very much in Tennessee. I guess there's some places with some pretty good changes of elevation, but you may not even need a pump at all. You could just use gravity if your water source was higher than where you wanted to deliver the water to. Now, to get that water out of a pond or a stream, you're going to have to start thinking about a siphon system to lift it out over the bank and then run it downhill to where you want it to be. To do that, this pipe, again, has to be a solid pipe of some form. It can't collapse because it's going to have negative pressure as you lift this water up out of this water source to get it over the hump. It's got to be solid. You can't lift water, and this is probably high. I should probably put 25 here. The theoretical max is about 30 feet of lift before you get so much negative pressure that the water comes apart and becomes vapor and you won't have your siphon anymore. But when you take into account some friction loss to get through all this, it's going to be a little less. It'll be more like 25 feet of lift is all you can expect to do with a siphon. Now, to get a siphon going, you need to trap water here with a valve. A foot valve would be helpful here. It lets water go in but not out. You could use a valve here and just dump water in it and fill this section, or you could use a priming pump to suck water up and fill this section. And then you got to close this off, open this valve, and the thing will start running. And it runs without, again, it's gravity driven. It runs, water runs downhill. And it really is pretty efficient with a very small pipe, about 1-inch lay flat, very little slope. I've estimated here, if you're only trying to move 1 gallon per minute, which is hardly a trickle out of your faucet, to go 1,000 feet, you only need 1 foot of slope. Now, to move a little more water, you might, in 1,000 feet, you might need 12 foot of drop, but that's highly doable in a lot of places in Tennessee. The problem is we don't often or always have water sources uphill to do this. And again, even with a little bit of water, if you let the siphon run 24 hours, it puts almost 1,500 gallons, and that would cover almost 60 cow-calf pairs. So that's a lot of water with a 1-inch system, very little slope, small pipe. Again, your cost there is going to be some of these bits and pieces, and this 1-inch pipe is not real expensive. It's probably about $90 for 300 feet instead of 120 or something around there. So anyway, if you have the right situation, there's a no pump, no energy solution that might work for you. Of course, there are existing municipal and home well systems or even irrigation systems scattered about the landscape that you could think about using. And I guess maybe one of the first questions that come up is, well, if we use city water, how expensive is it? Well, I did this just based on one of my own water bills. I guess everybody has a different water municipal system and cost, but I just took a month's bill and the amount of water I used and decided to get 25 gallons, how much it would cost per day, and it came out to 20 cents per cow-calf per day. So I guess I wouldn't necessarily be afraid of the cost of municipal water. Now, there's some upfront costs if that tap doesn't exist. To get your tap is expensive, but if that tap already exists, the cost is not that high for an emergency situation. And of course, in a home well system, it's even less expensive than that because you're really just paying for the electricity to move that water. Now, one limitation you may run into with municipal or home well is the amount of pressure available. A lot of times we want these systems to run around 40 psi of pressure because we don't want that much pressure in a house to break things up. And so if you only have 40 psi of pressure available, you're kind of limited maybe to 80 feet of lift. And again, I did the same thing here. I said, well, if you wanted to get 1 gallon of flow per minute out of a system like this, which would service quite a few cows, or maybe up to 4, which would service a lot of cows, what length with this system like this, with a 1-inch lay flat pipe, could you expect to go? So if you got up here at 80 feet of lift and you wanted 4 gallons per minute, you're not going to go very far. But if you only wanted 2, you could go almost a mile. So again, with this cost of this lay flat and the cost of water, if you don't have to pay to put a tap or you don't have time to put a well in, can be really a viable option for us to use in a time of emergency. One thing, important thing to remember when you start tapping into your own wells that you use for your own use or to a city source used by many people, you have to start thinking about backflow prevention and cross connections. We don't want to take contaminated water that's in these pipes that we're using for cattle and get it back into the system that people are using. So again, there would be another cost. Some of these, if they're allowable, are fairly cheap, but the best ones are, even in a 1-inch system, could cost you $300 or $400 for the best backflow prevention device available. So again, there's an option. I think that one's a pretty good one for a lot of us because there's houses and wells scattered throughout the countryside that could work for us. Let's see, I'm moving pretty quick. This is not going to be a very long webinar. One option that comes up, and I'm not sure it's very good for emergencies, but it's something to consider, is rooftop collection. Here, you can use any type of rooftop. These are high tunnels, but you can use barns or houses or whatever it might be. And you can capture a lot of water off of a structure. And I gave you a little idea with what size rainfall and what size roof. You can 1,000 gallons from a 1/2-inch rain on a 3,000 square foot roof. You can catch a lot of water. The problem is having enough storage available to store that for long periods of time. And that's why I don't think this is really in itself a good emergency way to work in an emergency. When it's not raining, you're not collecting any water, and it's hard to have enough storage to last a real long length of time in one of these tanks. Now, If you combine it with another solution where you're catching water all the time and getting benefit of that water, and then you have these tanks available as a place to pump water up to and store to use when it's not raining enough to fill these. I mean, I think that can fit into a good long-term water solution. But on its own, I guess well, there's one point where it might be better, it might be helpful in a drought. When it starts to rain again, and the fields are so dry, to get runoff to fill your ponds could be a while. It could take a lot of water. But these systems will immediately respond to rainfall and put water into them as soon as it rains. So that is one difference. You would get some water out of a rain event, which you might need. If it started raining tomorrow, rained an inch, we might not get much flow because of the dry soils into any of our other structures. So we would get immediate response with a tank. I guess I'm ready to summarize. I'm not sure if we'll have any questions, but I guess just to review, maybe you didn't catch some of these points with the details. You know, I don't know if you noticed, but the amount of water required for livestock watering is small, relatively small, especially if you're like me, you work in irrigation, it's really small, such that the limitation usually is not hydraulics or water or energy costs. Those things are really doable. Therefore, evaluating water source options based on capital investment and labor involved seem to be the more important thing to really think about. What kind of time am I going to have invested in this? What kind of money do I want to invest in something that maybe is only for a short-term solution? Also, whether solution costs can be shared with neighbors, I think it's a good thing to think about. Can you borrow someone's irrigation pump or pipe for a day and just rent it from them? Maybe there's some options like that would keep you from having to invest in something you don't use very often. I guess, again, this is hard to do on short notice, but I think a lot of times we got to think about the watering system we want every day alongside our emergency system to make sure those two things work together. So if we're investing in something that works for an emergency, it's also something that's helpful for everyday watering needs of our cattle. I think if we could do that kind of planning, that's hard to do when the emergency hits, but again, if we have time when there's not an emergency, to think about emergency watering and non-emergency watering at the same time, I think it would be a better approach. This last is just a little warning that I did a lot of this hydraulics on the quick. It's not really precision engineering, so you might need to work it out better for your actual situation. I ignored some things that, twists and turns in the pipes that cause minor loss, entry and exit losses, little things like that. And again, I need to mention that, sometimes you have ups and downs in a pipeline, and you got to purge air out of those high points or the system won't work very well either. So little things like that I didn't really cover. But anyway, I just really was trying to give you a feel for the engineering side of this and the technical side of this to make this work with what I did so far. With that, it seemed like a real short slideshow, but
that's actually that, Brian. That's perfectly fine. I think that you hit some points that are really important to consider, I think doing it in a concise manner here was great, talking about considerations of pumping it from one source to the other or the trucking. I know there's a lot of people right now that, and by a lot, I really do mean several across the state that have had to start hauling it. So those considerations about the size of the tank relative to how many head of livestock we have, that's extremely important. So no, this was really, I think, spot on what we needed to kind of get us started looking at it. And then, for the specific engineering components of it, as they get into it, could ask more questions and get into more detail as needed. But this is perfect for today. Have one question on the chat so far about local fire departments being utilized to fill tanks and ponds. Have you ever seen that kind of situation or have any experience with that, Brian or Jason, either one, as far as asking to see if a fire department would be able to do something like that?
I don't have any experience with it. I guess I'd just be guessing. I would think they're in a situation maybe with droughts where they're watching themselves for fire and things, and so I think they have to be a little bit cautious of just saying, if you do it for one, you have to do it for everybody, right?
Yeah.
And then they put themselves in a kind of a bind, maybe to do their job. But I guess the only way I guess you'd have to ask. I would think, as part of the community, they might be interested in doing it, but then they might have some limitations too about who they can serve. But
I have seen some situations out west where water is more of a concern all the time, where they have like community points to fill tanks like that. And it may be that you could ask a local fire department to use their filling system, what they fill their tanks with, if it wasn't in the way of their emergency response, to maybe more rapidly fill
Yeah,
tank on a trailer or a truck.
yeah. I was thinking more taking their engines out there and doing
Yeah,
it.
and I think that was the question too. But yeah.
And I don't have any specific experience working with a fire department to do that. But what I do know is that if you don't ask, it'll never happen.
You're right.
And so if it's an extreme emergency kind of situation, I'm going to do anything I can to try and get water. And so, I don't know until I ask. So I think it's definitely worth at least looking into. Some of that's also probably going to be dependent upon what their source of water is. So if it's municipal water and there is going to be a charge associated with that, that's something we also have to consider.
And there's a kind of follow-up question I had, who to talk to kind of start that discussion. And a comment here too, that there's a water restriction right now in Marion County. And I know that area down there, Matt, is where some of the more severe drought is in Tennessee, and then on down into Alabama and Georgia. There's more severe drought in those areas. And I saw a TDEC notice that under water restriction use. But the comment on kind of who to talk to, I would actually start with your municipal water source. So I have a friend here. I live in Murray County. I have a friend that oversees the water utilities in this area. And I would contact them as a county agent. I would talk to them and say, hey, I got some producers that need to be able to fill some tanks quickly, or maybe even see about getting some water hauled in an emergency situation, and see if they might have some resources that can help out with either filling tanks or getting it hauled, either one. So I'd start with the water, municipal water management, or just a city or county kind of a government, and talk to them and see where to at least get the trail started to look for some of that. It's a good question. If somebody has any more questions, go ahead and type those in the chat, and we'll respond to those as we go. Kind of ask Jason if he might make some comments about water quality. Brian had mentioned pumping from one source, maybe a river, a stream, or one pond to a tank, or that kind of thing. But ask Jason if he might make some mention on water quality, and if there's any issues that kind of pop out in the front of your mind, Jason, as we talk about getting that to our cattle just on a quality basis.
Yeah, I think that's something we always need to consider, especially when we're talking about changing sources of water. But even if we're not changing sources of water, and as a lot of the ponds that you see that cattle have access to stand in, the reality is they tend to use that as a latrine too. That may not be as big of a deal if there's water continuously flowing through it, but those stagnant ponds, as water is removed from cattle drinking it and it's not being replenished with rainfall, everything that's dissolved in that water that's in solution, it's going to essentially be concentrated. So as that level of that pond drops lower and lower, essentially we're taking the amount of dissolved compounds in that could be problematic, whether we're talking about harmful microorganisms or if we're talking about some of the mineral elements that can cause some problems, and we're concentrating them. All right. But aside from that, if we're starting to look at, and that's where I think we definitely need to start rethinking some open access waters for cattle. There are ways that even if we want to use that as a water source, we can decrease that risk by using some fencing systems to really limit the ability of cattle to spend time in that water. And that's where the NRCS group is a great point of contact, and through your county agent to try and identify what some of those options are. Now, in a more emergency situation, when we start looking at alternative sources of water, if it's crystal clear, clean type of water, we generally don't have any problems with it. But if we're talking about a new source of water that may be questionable, I think we always need to be thinking about conducting a water quality analysis in order to just make sure beforehand. So a more proactive approach at preventing some type of solute related problems that could occur. I get a lot of questions about sulfur because we do have a lot of locations across the state where you can smell sulfur in the water. And we did, as a part of the statewide forage mineral survey that was conducted in the summer of 2015, there were a lot of water samples that were tested, and especially looking at sulfur, and the highest sulfur level in a sample that we received, the sulfur level would have needed to have been at least 10 to 50 times greater than that to really be able to cause a problem in cattle or other livestock. So for the most part, if cattle will drink it, I don't think we're going to run into a problem with sulfur in our water. Where we run into problems with sulfur in water tends to be in some of the western states where it's really, really, really concentrated. But again, I think we need to be cautious as those water levels drop and cattle have had the opportunity to spend a lot of time in them as to if that water quality is indeed going to be an issue. And that's something that is going to affect water consumption. As you mentioned, Justin, at the very beginning of this, water is by far the most important nutrient. And when we start limiting water consumption because cattle don't like it, or there's a mineral or something in that water that's decreasing their consumption, we can cause some problems that way. And so that's where we need to be doing everything we can to get a good, fresh source of clean water to the cattle. I know that's not a lot of specific information, but from a general standpoint, I think those are some of the things we need to be thinking about with some of our current sources of water, and then some of those alternative sources as well.
I was thinking, I think maybe Justin asked this question back in 2012 about, I guess, in terms of water quality, some of the things I've shown is temperature. Is that a temperature of the water becomes a problem? I guess I'm not sure what temperature it becomes a problem. I know like black pipe and black tanks can absorb quite a bit of heat. And again, I don't think it's a problem if the water's moving, like you're filling a pond or filling something that's fairly sizable. Now, if you're slowly taking water out of a black pipe, it's probably worse than the tank. I have to go back and look, but I like those tanks I showed at the high tunnels. They sit there through the summer, and I think the summer water temperature is a little bit above the average temperature for the day. So if we were 80 and 90, it'd be 85 would be our average temperature. I think we're several degrees warmer in the tank water, like in maybe the high 80s or something like that. I don't know if that's a problem, but I know water that sits in a pipe and you just take a little bit of time out, it could be probably in the hundreds. But if we're moving a lot of water to refill something, that's not a problem either.
Yeah, that's a really good point, though, Brian. And I had forgotten about mentioning that. But especially if you kind of bargain shopping on the big tanks to haul water with, and you get one of those black ones and fill it up and let it set, and then put it in the next day, that temperature can really have a negative impact on water intake of the cattle. So really, really good point. A couple more questions here on the chat. One question here from Kristen about what's the best stuff to use to clean a water tank and how to keep algae from growing in it. When I do that, most of the time, actually, I just manually scrub it out and don't really use a lot of chemical or anything to get that done. It's just a matter of doing it often to keep the algae from accumulating in it. If you want to use like a light bleach, kind of a chlorine bleach mixture to put in there to scrub it out, just make sure you rinse it really well so there's not enough residue in there to give an off flavor, because livestock, or cattle or horses or sheep or whatever, might decrease their water intake below what they actually need if it has a different taste or palatability to it than what they're used to. So that's kind of my take on that. Jason or Brian, if you'd want to either have a comment on that.
Yeah, I've got a couple things to add to that. I think you hit it spot on, and just starting with a clean tank and keeping it clean. One of the things that I've seen that's been really effective is when we just try to keep some of the introduced feed particles and dirt and some of that kind of stuff out of it. Some of those pool skimming nets that you can buy fairly economically, they're worth their weight in gold at doing that. And the next thing that I'm going to say, I'm going to add a little disclaimer to it because I haven't seen any hard science-based research on this, but I have heard from some individuals that have tried this that a little bit of apple cider vinegar diluted in the water will substantially decrease algal growth in livestock waters. And so, that's something that it's probably going to change taste a little bit. So just like anything else, if we're going to make a change, we want to do it gradually. But a small amount of diluted apple cider vinegar mixed in the water, from what I've heard, seems to do a pretty good job of decreasing algal growth. I don't have any specific information in terms of amounts, but that's something where, again, if you start slow and work your way up, you may be able to try it, and if it's working, find whatever that necessary level might be, as long as you're noticing or making sure that it's not really changing water intake.
I had a comment, maybe as a or question on some of the tanks that you've worked with cleaning out. Have they been black, or have they let light into them?
Most of the tanks that we're doing, Brian, just let you know that these questions are coming in on chat because it's a webinar series here, but or a webinar style. But most of the tanks that we would deal with are either going to be those metal, some sort of a metal tank, or a solid tank that doesn't let light into it as far as the actual watering trough. As far as tanks to haul in and that kind of thing, if you get some algae accumulation, which inevitably would, or over time, would be those kind of opaque that don't let enough light in really, I guess, to kill any thing, or to enough to promote, I guess, algae growth, if that's what you're thinking.
Yeah, I guess I haven't worked with a lot of dirty tanks, but the ones that we collect rainwater in, I've been surprised that with being black and being very low nutrients from the rainwater in them, I let one sit for over a year and came out with a Clorox bottle to clean it up, and it didn't really need it. So I was just...
I've seen a lot of algal growth in stock tanks or water troughs of all different colors, shapes, and sizes. I think one of the big things is whether there's actually some additional organic matter that's going into the water to
From
provide
livestock actually
be necessary for that algal growth. So if you can prevent that, I think you can really prevent algal growth. But the reality is most of the time we can't. So we've got to react and try and get it out of there once we see it. But even on an every few day basis, just going through with a little bit of with a net or something like that and pulling that organic matter that's in there out seems to do a pretty good job.
Yeah. Got a couple other questions here similar in the chat box from Matthew and Mary Ann about having water tested, where we can have it tested. Did some work with this, trying to figure that out, I guess 3 or 4 years ago. And the best place I came up with actually is a water quality lab at Tennessee Tech University. I don't have the contact information readily available here with me, but I'll post it on the Drought website where this recording will be, and the rest of our other drought information. But testing water is kind of a fickle thing depending on what you're trying to have tested. It needs to be done really, really quick and just have it planned out, where if you're going to use that lab at Tennessee Tech or a commercial lab, wherever we end up finding, it needs to be a really fast turnaround from collection to analysis. So planning it to where you take it that morning and have it to the lab that day to get the most solid analysis on that. Jason's put in here in the chat box, if y'all can see that, the resource for Tennessee Division of Water Resources. Got a number here. And Jason, do you want to just...
Yeah. So that number, and this is just what I found online, and this is actually through a web-based extension publication, but that number is 615-532-0191. And you can call that number and ask for a list of commercial labs that are approved for water quality analysis. And there tend to be a lot of regional water quality labs, and that's one resource where some of the NRCS folks can come in and help and maybe make a recommendation as to who they may be working with and some of that kind of stuff. just to identify that lab that's going to be nearest to you. There's related to that. There is another question from Marianne Ike, and it asks if should she have her pond water tested. And that's a question that's always going to be dependent upon the scenario. I think if we're in a situation where we've been using that pond to allow cattle or other animals to drink out of for a considerable amount of time, we haven't seen or observed any problems, and we haven't really observed a lot of change in that pond, I don't think we should be recommending that everyone goes out and just test that water. Now, if it's never been tested before, yeah, just from an information standpoint, it may be something that's good to do so you know something about the water quality going into your animals. But then that's going to also take some interpretation through your county extension agent, and then potentially with some state specialist involvement. But if we're in a situation where we're using that new water source, or we're seeing a considerable change visibly in terms of what looks like water quality, then that's something we definitely may want to consider. We do hear about some fairly regular problems, especially in the middle of the summertime across the state of blue-green algae, and it causing some problems in livestock. And so it's just some of the things we need to think about. But there's no good yes we should or no we shouldn't answer to that question.
We got another question here too about advice on keeping water tanks from freezing. And Brian, this may be something you want to add some comments if you can think of anything off the top of your head as far as the transport stuff and the dynamics of keeping it moving or not. But as we get into the winter situation, if we haven't had any rain to refill stock ponds or to get moving water flowing again that we might be relying on for livestock watering sources, this may actually become fairly problematic if we're trying to fill up a tank and let it sit for a while and get some freezing around the outsides of it or in the pipes enough to keep it from flowing. So, in the actual, we'll just work with the actual delivery mechanism, the tank that they're drinking from, and then kind of move back from there. But, there's frost-free waters. If you happen to have one of those types of waters that a ball water that would have a heat well associated with it, that would be something that's already in place. Or if you can run electricity to it, there are devices to put in there to keep the water from freezing at the top. It may be a situation where if you have refilled a stock pond by pumping like Brian was talking about, you'd need to go in and break the top of it if you get some freezing on the top of it, or go in and just break the top off out of the water troughs if they freeze over. So again, just some diligence to keeping up with that, either an electric device, a heat well associated with the ball water. When you get back into the pipes and the tanks and stuff, it may just be that you have to purge the line of water each time that you move the water. Brian, maybe that'd be a way to handle that.
Yeah, we don't get real cold weather here, but we can get some cold weather. Now, if the tanks are sitting on the ground, or sometimes we bury them just a little bit, just the bottoms of them, that heat from the ground, I guess I'd have to go back and check my temperature data. But if a tank's sitting on the ground, gets some heat from the ground, and is sitting in the sun because it's black, it needs to be, the average temperature needs to probably be below 32 for quite a time period, or into the mid-20s for it to freeze. So I don't think as soon as it gets cold, the necessary tank's going to freeze. Now, yeah, when the ones that are up on a truck or something like that, and if it stays below 32, again, the sun can help if it's sitting in the sunshine, not in the shade, help keep that warmer even if it's freezing. But yeah, it can freeze. I don't think my experience is it hasn't broken the tanks, but our problem is getting water out of the tanks. So yeah, I guess maybe there's some household things you could, with a extension cord, but I hate to recommend anything
right
with electricity and water to do that. I think as far as the pipes themselves, yeah, if we have slope and you make sure the water's evacuated, there's going to be some freezing where a little water's sitting here and there, but it's not going to freeze solid and keep you from watering. And then again, if the water is liquid and it's moving when it goes through the next time, it really, unless it's really cold, it shouldn't freeze. I guess I'm not sure if I'm envisioning all the situations people might get into with pipes and tanks, but yeah, there's above ground. Yeah, water sitting in an above ground tank is more likely to freeze for a long time.
I guess the best we can do really is just think about keeping, if it's going to stay cold for a long time, and we're still having to deliver water to through some above ground pipes to keep those purged out every time we use them. Like we do, water hoses or whatever when we're generally doing that, maybe in a barn situation or something.
Justin, just a few things that I'd add to that, and to reiterate what you said about pipes or hoses. Come wintertime, we're pretty much going to need to be removing all the water that remains in those hoses before we let them sit overnight for the most part. And so whether that's physically pushing the water through them or just elevating them and running down the line to make sure that it's running out the end, and making sure those are going to be disconnected from our fittings, whether we're talking about a spigot or we're talking about the end of the tank, to keep it from freezing there. From a water trough standpoint, even if we're hauling water to the water trough, or we're just talking about trying to keep troughs from freezing in the wintertime, a lot of troughs will have that drain plug at the base of them, and there are a lot of plug style insert heaters that go into that plug, and they replace that drain plug, and they're electric. So as long as we're in near enough proximity to electricity, then they are very, very effective at keeping troughs from freezing. That was something about this time of the year. Growing up in Northern Virginia, we would change our plugs out and put the heaters in right about now, and they would stay in until mid to end March, just to avoid some of that. They're floating style heaters. I don't like them as much, just because it seems like there's always more of a chance of the potential for shock with something like that. So we always tried to avoid those, but there are some plug style insert heaters that are really effective. If we have automatic ball style waters, most of those have the ability to or options to accessorize them with a heater, but again, that's going to require electricity. So without electricity, there's really nothing we can do to keep it from freezing. If it is freezing, we need to make sure that we're breaking it at least twice a day for the animals, so they have plenty of opportunity to drink. If we can also increase the rate of water movement through that tank, so we don't have a tank that's a lot larger than we need, we tend to increase the amount of time that it takes for it to freeze, because we got more water circulation, and then we're changing the temperature more regularly. So those are some things that can help out as well.
All right, thank you. Don't see any more questions or comments coming into the chat box, and getting kind of close on time. So just leave a couple more seconds here, or a few more seconds. If anybody has some questions to type in the chat box there, go ahead and do that. But I think we've pretty much covered the basics of where to start. Brian, awesome job. Really appreciate you being, again, willing to do this in a quick turnaround to get this up for people to start considering what it's going to take to move some water. Some folks are already doing that and may be able to use this to do that more effectively. So appreciate it.
Okay, thank you.
But, all right. Well, I don't see any more questions coming in the chat, unless anybody has anything else to say, the three of us panelists, then we'll go ahead and call it good. Okay. All right. So we'll get this posted up, and if you're watching the right now live, or if you're watching this as a recording, I'll always say that you got the University of Tennessee Extension in every county. So if you have questions about this or other things relating to drought or production of any type, contact your local ag natural resource UT Extension agent, and if they don't have the answer, then they'll find somebody that does. So best of luck trying to get through this, and hopefully we'll get some rain. So take care.
All right, thank you.